Hello, this is Dr. Christy Patton Lukes, a chemical engineering professor at Missouri S&T. We are doing lessons for process control. These lessons are based on the textbook by Dale Seaborg, Thomas Edgar, Duncan Mellenchamp, and Francis Doyle, and it's published by Wiley. We are working out of the fourth edition, but at this stage of the course, any of the older editions also have very similar information. So now let's get started with Chapter 3, Laplace transforms. Let's continue now by looking at more uh, solving inverse Laplace transforms as if we were doing a differential equation, but this time we're just going to be starting kind of in the middle of the problem and really focusing on the partial fractions expansion. This problem is a little bit different because it has a power on one of the pieces in the denominator. That means it's a repeated factor. And in that case, I'm going to use that repeat to modify my partial fractions expansion. Now the first piece is just going to be something over s. And my last piece is going to be something over s plus 2. That part's not weird. What's going to be different is this piece here. So I have s plus 1 squared. What I'm going to do is I'm going to have s plus 1 and s plus 1 squared. If I had s plus 1 cubed, I'd have s plus 1, s plus 1 squared, s plus 1 cubed. I'm going to count up as many times as I need to for that power. And then each of these are linear in the denominator, so I'll just put a constant in the numerator. Okay, so that's going to be a little bit different, but our technique is still the same. Multiply through by the denominator. And on the left-hand side, we just have 2 left. For the first term, a over s, the s is going to cancel. I'm going to have a times s plus 1 squared times s plus 2. B is going to have the s. It will have one of the s plus 1s. 1 will cancel, and s plus 2. C, I have s. Both s plus 1s cancel, and s plus 2. And I'll have d s plus 1 squared. Now this is where the technique of using the zeros can be helpful, because at this stage I start looking at this and thinking, I don't want to multiply out all those binomial theorem things, right? Yuck. So let's start by using the zeros. So I have, for this first piece, s equals 0, and I substitute that in. 2 equals a times 1 squared times 2, plus 0b, 0c, and 0d. Therefore, a is equal to 1. For the next piece, s plus 1, the 0 is s is negative 1. And so 2 is 0a, 0b, c times negative 1 times 1, and 0d. Therefore, c will equal negative 2. And if s is negative 2 from this term, then I end up with 2 is equal to 0a, 0b, 0c, and d times negative 2 times negative 1 squared. So negative 2d equals 2, d therefore equals negative 1. Now that got me 3 of my answers, not the 4th. And at this point I could plug those in and then use the original technique, or I could just make a random choice, okay? I'll choose s equals 1. It's not a 0, but I don't have much left that I need to learn. So if s is equal to 1, 2 is, a is 1, 1 plus 1 is 2 squared, 1 plus 2 is 3, plus b times 1 times 2 times 3 plus c, oh wait, c is negative 2 times 1 times 3 plus d, negative 1, times 1 times 2 squared. Okay, so 2 equals 12 plus 6b minus 6 minus 4. All said, b is equal to 0. Therefore, y of s is 1 over s minus 2 over s plus 1 squared plus, or I guess minus 1 over s plus 2. And now to do the inverse Laplace transform, 1 over s is going to be the constant or the unit step function. 2 over s plus 1 squared, this is going to be a polynomial piece multiplied by the exponential. In this case, it's minus 2t e to the negative t. And then the last piece is just the exponential. Okay. Now, if you have something where something on the top, something, and then you have like s squared plus 3s plus 55, I don't know, something not factorable. Okay, in this case, you would have like your a over your whatevers. And then for this piece, that's the s squared plus 3s plus 55, that's not factorable, you would put a polynomial that's 1 degree less in the numerator. Okay? And there's lots more of these little tricks we can do. Fortunately, we don't really need to do very fancy partial fractions expansion, and what I've shown you is really the main things that we end up needing for our purposes. Now, in the next video lesson, I am going to be showing you ones where you cannot factor it and how to solve for what's left. Okay? And that's going to use a skill called completing the square. All right, catch you in the next video.